Hello everyone, hope you're all doing great. Recently I had chance to investigate on the outage on the DynamoDB service in the North Virginia US East 1 region, and in the process I had a good amount of learnings and I thought I could share with you all. Coming to the problem description, there has been a major outage on the DynamoDB service in the US East 1 region, and it has started on October 19, 11:48 p.m. PDT, and it continued until 2:20 p.m. PDT on October 20. So this information we got from the public notification given by the AWS itself. Now, this is a huge outage. If you look into the DynamoDB service SLA, it is expected to be 99.99% available or close to 99%. So over the half day, the customers were unable to access the DynamoDB service and it is a zero downtime. And top of that, US East 1 is a major region. Multiple organizations and even internal AWS teams depends on US East 1 region and the services offered through this region. So this is a huge outage, and it encourages us to know what actually happened that led to this outage. Now, this image, if you can look into, is from Down Detector. It actually tells you what all the sectors got affected because of this outage, right? So internal to AWS, multiple AWS services also got affected. We look into what could be the reason why this cascaded effect has led to due to the DynamoDB service disruption. Like you can see, the Lambda got affected, EC2, even the ECR, and even the Route 53 DNS and traffic got affected. Even Amazon retail and e-commerce uses the US East 1 region, majorly, and even some of the Amazon services like Prime Video also got affected. Alexa, Ring in the IoT sector and in the banking sector, Lloyd's Bank, Venmo, in the social and messaging, Snapchat, WhatsApp, Signal, right? So this has been outage that has affected multiple organization in multiple sectors. Now that actually shows the dependency of the AWS cloud on or across the world, right? So it is more interesting to understand what actually caused this issue because the dependency and the customer impact is pretty high, and there has to be some big reason why this could have happened. Now, before jumping into the actual deep dive on this issue, I think we need to understand some of the fundamental concepts so that we can understand the issue itself in a better way and ensure that we practice the learnings in our work as well. In this section, we talk about the fundamental concepts like DNS, load balancing, availability regions, AZ local routing, what are AWS regions, Route 53. These concepts will help us to understand the outage issue more better. If you think you're already aware about these concepts, please proceed with the deep diving section. I'll add more details in the video description. Right, coming to DNS, what is DNS? DNS is abbreviated as Domain Name System. You can think of it as a phone book where we maintain phone numbers and the corresponding names, right? So similarly, to identify any entity on the internet, we need something called as IP address, and it is composed by numbers. You can see it here. So it is hard to remember these numbers. So the developers came up with this concept where they maintain records of these IP addresses and the domains. So when I say domain, it is this something that we enter in our browser. That is, let's say www.amazon.com. So for resolving this domain name to a particular IP address, this whole process we called as a DNS resolution. There are some series of steps that happens in the backend to identify this IP address. Let's look into it more deeply to understand it better, right? So DNS hierarchy is read from the right to left. Let's take example of www.amazon.com itself. Here, when we want to interact with the amazon.com servers, we make a request from our client. Our client will be using the our internet service provider resolver. This will help us to interact with the .com server. So .com is a top level domain, or we also call it as a root servers. These are maintained by different organizations under ICANN. So this .com server do not know where Amazon.com is, but it at least knows where Amazon domain is. It is a second level domain. So when a client requests for the IP address, the .com server will route the client to the Amazon DNS server. Now, Amazon DNS server, we can call it as an authoritative DNS server here. That means it has the ability to provide the final answer. Any DNS server that provides the final IP address, we can call that as an authoritative DNS server. So Amazon DNS server has the IP address, and www is basically a subdomain as part of the Amazon domain. So it has the IP address, and when the client requests, it will be getting back the IP address, and the DNS resolution completes. This is a whole process, and we can actually look into this DNS resolution process by using a utility called dig. Let's see in the terminal how it works. So I'll just enter dig www.amazon.com. Now it has returned me some information. Let's see what it is. In the header section, we are saying we are making a query, DNS query, and these flags indicates that we are going to do a recursive query. So as explained before, it happens a recursive way. First we go to the .com server, and if it do not have the answer, it will route to a different DNS server, that is Amazon, and then finally we got the answer from the Amazon authority DNS server. So it happens in a recursive way. So we are saying the server that we are trying to interact, it supports the recursive query, and it is saying here we got three records, three answers. In the question section, we are saying I want a record. In DNS term, a record is what will have the IP address, right? So we are requesting a record for the Amazon.com, and in the answer section, we got three names. So www.amazon.com is a C name, is a canonical name, or is a different name you can think for this. Now, for this domain, the C name is the CloudFront. So CloudFront is a different concept which will help to increase the availability overall the world. Like it has some mechanisms like caching and all that to improve the customer interaction latency, reduce that latency of response. So Amazon is also using the CloudFront here, and the CloudFront, finally the CloudFront's a record is this IP address. So our client will be now be using this IP address to interact with the Amazon.com servers, right? Yeah. So this is the TTL. So TTL is time to live. It is abbreviated as time to live. It will it will tell you how long an IP address can be cached in the local browser. How long an IP address can be cached in local browser. So we do not need to go through all this DNS resolution again, because ultimately if you want to interact with the servers again and again, we do not want to do this resolution. It increases the latency. So we perform this caching process. So Route 53 is a DNS as a service provided by the AWS. So it helps us to maintain these records like a record or NS record. NS record means name servers record, CNAME records, right? So it's a DNS solution provided by the AWS. Now let's understand what are AWS regions and AZs, right? So AWS region is basically a geographically isolated region, and in that region there are multiple data centers deployed, and AWS have multiple regions like this, and they are completely separated so that even if one region goes down, through another region we can provide the services through to the customers, right? So AWS have these different regions, like North Virginia, Mumbai, Ireland. So each region has its own services. And what is availability zones? So within the each AWS region, we have availability zones. And these availability zones you can think of as a group of data centers which are isolated, which have its own networking connection, cooling systems, power supplies. So it's completely isolated. So this is helping to create a fault tolerant and a redundant system. So if the customer is interacting with this AWS region and one AWS availability zone is down, then the customers can still be utilizing the services to different availability zones. So that is the purpose of the availability zones. Alright, so what is load balancers? Load balancer generally helps you to control the traffic that comes from the clients. It helps you to distribute the workload among these servers so that not a single server is overloaded with more traffic. It keeps in mind like how many connections that are already been to the a specific server, what are its resources utilization, um, is it healthy, and all these features are provided by the load balancers. So in any modern architecture, right, and if it is a scalable architecture, we would want to use this load balancers to control our traffic, right? So it uses different mechanisms to route the request and distribute the workload. Some are like round robin. It's basically like if you get a request and if you assign that to a server, the next request will be assigned to the next server in the order. Or it has this least connections. The load balancer will keep a track of the connections that have been made to the individual server. If it has least connections, it will try to send the traffic to that specific server. And there is something also called as a weighted round robin. Whichever server's IP address have more weight, the request will be routed to that particular server. And we also call as IP hashing, where the request will be sent to a particular IP address itself. This will be helpful in creating a sticky sessions, especially if you see in the banking applications, right? We do not want to switch to different servers. It maintains a session, right? After the session, it closes. So in those cases, also load balancers helps us to create this sticky sessions. There is also a concept called as a DNS load balancing. Here, DNS services like Route 53, which I mentioned, will help us to manage the load that comes from the client for DNS queries. Like, let's say I'm requesting a website or a domain as app.example.com. The Route 53 will return with a set of IP addresses. Now, Route 53 will decide which IP addresses I can return to the client in such a way that I can manage the traffic. And these IP addresses are refreshed at a regular cadence, especially in systems where there is a high traffic. We want a mechanism to ensure that the request is going to all the servers. So here Route 53 can help us to balance those DNS queries. Let's look at this table, right? app.example.com, a record. A record is directly maps to an IP address. And here we are assigning some weight to it, 70. And similarly, another A record, we are assigning some weight to it. So when a client requests Route 53 for an IP address, it will return the IP address that has more weight. And this weight is calculated by different attributes like what are the connections, what is the CPU resources, can I send the request to that server or not. So based on some algorithm, we decide this weight and assign that to the IP address. This is called as a weighted A record assignment. So the Route 53 will return these IP address that has the more weight. So in this way, we can control the DNS load balancing. A single load balancer is usually deployed across different AZs, and this will help us to route the traffic between the different AZs, not overloading a single AZs. So these are some of the benefits and advantages of having a load balancer in our system. Now, what is AZ local routing? Just now we talked about load balancer being deployed in the different AZs, right? So usually if you want to route a request originating from one AZ to a different AZ, it takes more cost because the obvious reasons of networking, and it takes more time as well, right? It brings some kind of latency. So in Route 53, we have this concept called as AZ local routing, where the the resolver will know whether a request is originated from a specific AZ or not, and based on those details, it will try to ensure that the client is talking to a load balancer that is deployed in a specific AZ. Now, what this is helping is to reduce the latency, and also it is helping to um, ensure that the requests are only scoped to a specific AZ, right? Yeah, that's a little bit about the um, AZ local routing. Now let's combine all this concept and look into this diagram. So we have a DNS query. We are taking help of Route 53 to get the IP addresses so that we can interact with the specific EC2 servers. It's deployed as part of a VPC, and each load balancer is available in a single availability zone, and it is helping to interact with the EC2 instance. Now, in terms of AZ local routing, the Route 53 is capable of returning the IP addresses of these load balancers based on the region where the request has been originated. Right now, this is helping to ensure the requests are going to only specific availability zone. Yeah. So now, using all these concepts, let's try to understand what was the issue that caused the DynamoDB service outage. Now that you are aware about the fundamental concepts, it will be easier to understand this outage more better. I have created this diagram based on the public summary provided by the AWS. I would highly recommend you to look into the article. I will provide that in the video description. Now let's understand this diagram more better. So this is part of the automation system that is helping the DynamoDB service to perform its DNS load balancing and also utilize the features such as AZ local routing by the Route 53. So what is the job of DNS planner here? So DNS planner basically creates the change plans that consist of their domain details and also the fresh IP addresses and assigns some form of weights to it. So weights will help the Route 53 to decide which IP addresses it needs to send when a client requests the Route 53 for IP addresses. So that's the job of DNS planner. It creates the change plans. And DNS enactor is an independent job. It basically reads those change plans from the DynamoDB and updates the Route 53 records. So during the updation process, it actually checks whether the current Route 53 record is it older or newer. If it is older, then only it proceeds to the updation process. Now this is where the issue has happened. So let's understand this step by step. Okay, so the first DNS enactor, it picked up the change plans from the DynamoDB and it performed the validation whether it is a newer or older, and it got to know that it is older, so it went ahead into the updation state. During the same time, the second DNS enactor also read the change plans related to the same domain, and it also performed its validation, and it got to know it is older, and it went into the updation state. Now, since the first DNS enactor is already performing the updation process, the second DNS enactor has to wait. Now, the other delays also contributed to its latency, like maybe networking issue and all that. So the second DNS enactor is in a state where it has passed the validation phase and it is in updation phase. But the first DNS enactor has already performed the updation and it entered into a deletion phase. Now, the second DNS enactor Since it has already performed the validation, it went ahead and updated the newer record that were provided by the first DNS enactor with the older record that were held by the DNS second DNS enactor. Now the Route 53 is left with a stage where the top level record, you can refer to this level, this is a top level record, you can think this is a backup record. Now Route 53 is left with a stage where the top level record is with the older IP addresses, which is provided by the second DNS enactor. Now the first DNS enactor is in a deletion phase. What a deletion phase does is basically checks whether the IP addresses are very old. If it is very old, then it deletes. So that's what the first DNS enactor does. It got to know the IP addresses that are currently available are very old. It went ahead and deleted it. Now the Route 53 is left with the top level record with no IP addresses. It's an invalid target. This has left the Route 53 records in an inconsistent state. Because of this, the DNS enactors were also not able to update the records. I'm presuming Route 53 was not allowing to perform this updation because the top level record are invalid. So this has led to the failure of the DNS automation, and a manual operator has to pitch in and resolve the DNS discrepancies. After that, the clients were able to successfully access the DynamoDB endpoints. Now, the other services also got affected, like Lambda, EC2. These services basically internally uses DynamoDBs in their operations, like for storing the instance states, like EC2 instance states, or Lambda might be storing its metadata. So internally, also these services uses DynamoDB. So that has resulted in a cascading effect and created this high severity outage. Yeah, so that's about this outage. Hope you guys enjoyed the explanation. Hope it made sense. Please do like, share, and subscribe. And if you have any other thoughts about this explanation, please do provide that in the comments. I'll be coming up with more of this deep diving videos. Thank you for watching.